Hi, my name is Dr. C, and with this question, we are going to construct a 90% confidence interval of a population proportion. So the first step that I always recommend that people do, and it's not really a step, it's just kind of uh, taking on good habits, is to write down the formula for proportion, which is always going to be x over n, the formula for q, which is always 1 minus the proportion, and then the confidence interval. So when it comes to proportion, we have the proportion plus or minus the z critical times the square root of p times q divided by n. The z critical times the square root of p times q divided by n is what's known as the margin of error, and we're going to walk through how to calculate all of that. So the first actual step is stating the given. So again, the problem already gives us this x equal 120 and n equals 200. So we have that here. So from there, we calculate the proportion, which is 120 over 200, which gives us 0.6. So again, we calculate q. So in order to do that, we do 1 minus p, which is equivalent to 1 minus 0.6, which gives us 0.4. So because we're doing a 90% confidence level, we need to understand how to effectively do that. And the best way to do that is to do 1 minus 0.9. That gives us 0.1 as our alpha. And then because we're doing alpha divided by 2, that gives us 0.05. Well, if it's 0.05 for our alpha, keep in mind that alpha is the probability of making a type 1 error. So if we're doing a 90% confidence interval and we have it at this rate, that means that we need to be a certain percentage confident. So if alpha divided by 2 is 0.05, that means that we're looking for the remaining, which is 0.95. So what we would do, we would go to our handy dandy z-score chart, and we would look for 0.95. So we're looking, and we don't exactly see 0.95, but we definitely see that 0.9495 and 0.9505. So that means that our z-score is approximately in the center of these two numbers. So we would take 1.64, and then we would take 1.65, add them up, divide them by 2, which gives us a z-score of approximately 1.645. Okay. Next step would be calculating the margin of error. So again, the margin of error is our z critical times the square root of p times q divided by n. Because we did all the major steps in when we stated our givens, we already have this, so we can just kind of plug everything in, right? So from here, we have that 1.645 that we just found times the square root of p, which was 0.6, times q, which was 0.4, divided by n, which was 200. And when we did all of that, that gave us a margin of error of 0.057. Okay. After that, we would calculate the confidence interval. So if you remember, the formula for the confidence interval is the proportion plus or minus margin of error. So that's z times the square root of p times q divided by n is margin of error. So we can just do confidence interval equals the proportion plus or minus the error. So 0.6 plus or minus 0.057. So when we subtract it, it gives us 0.543. And then when we add, it gives us 0.657. So that means our lower bound is 0.543 and our upper bound is 0.657. So hopefully that answers the question. If anybody has any questions, let me know.